Alrighty, everyone, we're going to kick off. So thank you all so much for joining us tonight. I'm Shannon. I'm a marine campaigner with the Victorian National Parks Association, and together with Paul at Lifesaving Victoria, who's just on the screen there, and Hayley from the Association of Bayside Municipalities, we have been facilitating these series of webinars called The Nature of Change of Port Phillip Bay, where we explore the changes over time of the bay and beyond, the incredible ecosystems, and hear from experts about how the bay is changing both above and below the surface. So tonight's focus is called Weathering the Change, and we have two great speakers from BOM, the Bureau of Meteorology here, Grant and Jonathan, who are also on the screen. Thanks, guys, so much for joining us tonight. And they're going to be sharing with us the science of weather patterns, their impacts, and also how southeastern Australian marine waters are a climate change hotspot. So before we get into the speakers, we'd like to take a moment to recognise that different parts of Port Phillip Bay are part of sea country for the Bunurong people on the eastern and northern sides of the bay, and Wadawurrung people on the western sides. And there's such a rich cultural history here that has been alive for thousands and thousands of years. So we wanted to acknowledge elders, past, present and future, and thank all traditional custodians for taking great care of Port Phillip Bay over these years, and for giving us inspiration and also guidance for more aligned ways of how we can live, work and play on country. So how tonight will roll is we will hear from Jonathan and Grant, and then we will finish with a Q&A section. So if you have any questions throughout the evening, please go ahead and pop them in the chat function, which is the Q&A section towards the bottom of your screen, where you can type in any questions even as the speakers are going through their content tonight. And towards the end, we will do our best to answer as many of your questions as possible. And no doubt there will be plenty of questions because we've got some really interesting stuff to share with everyone tonight. So I will hand it over to Paul, who's going to give an intro to Jonathan.
Thanks, Shannon. And again, it's Lifesaving Victoria's great pleasure to be involved in this great project, hopefully providing education to our members, particularly our 26 lifesaving clubs that are located around the bay. And it's my great pleasure to introduce, first of all, Jonathan Pollock, who's a senior climatologist with the BOM. He works in hazard preparedness and response team that covers South Australia, Victoria and Tasmania. His focus is engaging with the Australian community and the emergency management sector, in particular regarding long-range forecast and for contextualising the current weather with Australia's historic climate data. His presentation today is observed and forecast changes around Port Phillip Bay, including temperatures and coastal inundation. So please join me in welcoming Jonathan. Thanks, Jonathan.
Thank you, Paul. Thanks, everybody. Let me share my slides. You should be able to see a presentation now. Could I just get a confirmation?
Yep. Perfect.
Fantastic. Thank you for the introduction. So for my part of tonight's presentation, I'll start off by setting the scene, and we'll have a little look at some of the climate change trends we've observed and what we expect to see in the future. And then we'll have a bit of a chat about our natural climate drivers and how those two forces intersect and impact weather at a seasonal timescale. And then I'll touch on some of the interesting recent rainfall and temperature patterns that we've seen since the end of last year. Before I hand over to Grant, who'll cover more about the trends in the oceans and local waters. So global warming is due to heat-trapping greenhouse gases in the atmosphere. So on this slide, we've got a time series of the CO2 measurements taken at the Bureau of Meteorology's air monitoring station at Cape Grim in Western Tasmania. And you can see it's almost a continuous rise since the station started monitoring back in the 70s. And not only has the CO2 levels been rising, they've been accelerating. So you can see in that breakout box Each decade, we've seen higher and higher increases in CO2. And temperatures have responded to those greenhouse gases. On this slide, we have a time series of global annual mean temperature anomalies going all the way back to 1850. And each of those blue bars is a cooler than average year, and each of the red ones is a warmer than average year. And it's pretty clear. You can see that we've got all those warmer years stacked up in the more recent decades and all the cooler years back at the beginning of the record. And when we're looking at the globe, we've seen warming of around 1 degree across that time since about 1850 to now. But it's not just land areas that are warming up. Most of the heavy lifting so far has been done by the oceans. And Grant's going to go into this in a bit more detail, but I put up this trend map just to illustrate, like Shannon said before, it's southeastern Australia, or the waters off southeastern Australia, are one of the areas that is changing most quickly across the globe. For Australia, our climate's warmed by around 1.5 degrees since 1910. And on this time series, on this slide, this is for Melbourne, you can see that a lot of that upswing happened since around 1950. The other thing you'll notice is that when we pick out a particular location, like Melbourne in this example, there's a lot more variability year to year. There's a lot more noise compared to that global time series we were looking at just a couple of slides ago. It's not just mean temperatures that are increasing, it's also the extremes. So when we look at trends in the hottest day of the year, we can see that those extremes, those hottest days, they're getting warmer decade after decade as well. And again, it's parts of southeastern Australia that have some of the greatest or the highest rate of change. That's a map for maximum temperatures. But we see a similar pattern for minimum temperatures too, with those the warmest night of the year, generally getting warmer decade after decade. And again, the southeast of the country, a bit of a focus for some of the greatest change. It's not just temperatures that have responded to those greenhouse gases. We've also seen changes in our rainfall patterns. On this map on the left, we have cool season rainfall, which is the April to October rainfall for the last roughly 20 years, compared to all years back to 1900. And what that map illustrates is that for the mainland, or the southern parts of the mainland, the most recent few decades have been drier than the earlier part of the record. And you can see there's a time series of rainfall anomaly for southeastern Australia in that plot on the right. And you'll notice that since about the 1990s, we've had a bit of a step change for southeastern Australia, corresponding to around a 10% reduction in that April to October rainfall. When we try to visualize what the future looks like, we can think of places today that have temperatures a bit warmer and conditions a bit drier than Melbourne is now. And so we find ourselves by 2050 comparing Melbourne to places like Wangaratta, Benalla or Albury today. And now I want to talk about how some of those changes intersect with our natural climate drivers, specifically the Indian Ocean Dipole and the El Niño Southern Oscillation, and how they impact the seasonal weather that we have from year to year. Because it's really changes in these natural drivers that provide us some of that year-to-year variability on top of those longer-term climate change trends. So you might be aware we had an El Niño event last year, and that's still going, although it looked as though it peaked at the end of last year. And there's good agreement between the international models that we'll see that event continue to cool and will return to a neutral ENSO phase during autumn. But there's a bit of conjecture, a bit of disagreement between the models as to what will happen later on in the second half of this year. We've mentioned that we've seen around 1.5 degrees of warming across Australia since 1910, but it's also worth noting that more recently we've seen some extreme temperatures, extreme sea surface temperatures across the globe. Area average globally, sea surface temperatures have been the warmest on record from April last year through to February this year for each respective month. I haven't seen the final figures for March, but March 2024 was also trending towards warmest on record. And so in some ways we're in uncharted territory because we haven't sort of tried to forecast with these types of conditions before, and we haven't had any comparable years in the past that have had sea surface temperatures quite this high. So looking a bit more now at the different international models forecast for the El Nino Southern Oscillation, that plot in the top left, the dashed black line, those temperatures in the Nino 3.4 region, which were at El Nino thresholds, and they sort of peaked at the end of last year. And you can see they've turned a bit of a corner and they're beginning to cool. And then all those colourful lines from the point that says now, they're the different forecasts from the various international agencies. So we don't just look at our own Bureau of Meteorology forecast. We also compare it to the forecast from Canada, from Europe, Japan, France, America, and the UK. And when the different methods are in agreement, we have more confidence in the forecast. And when they start to show a bit of disagreement, we have less certainty in what they're telling us. So for the near future, there's pretty good agreement between those models. The temperatures will return back to that middle white section of the plot in the neutral ENSO phase. But then you'll notice some of the models are a bit cooler than others, and they sort of push down into that La Nina territory closer to winter. It's the Bureau's model is the dark red line. It's worth noting that we're one of the warmest because that will impact the amount of rainfall predicted in the coming seasons. Now below that, there's a series of bar charts for April, May, and June showing a similar story. So they've got the outlooks from the various model agencies. The Bureau's is the one at the top. And you can see that as we move from April through May into June, some of those models cool down, and we've got the American and the UK model pushing into that La Nina territory during June. And the reason we get excited about La Nina or El Nino is because we know that from the past that it has a relationship with rainfall patterns across Australia. So on this slide, I've got two maps, and they're not the forecasts for the coming season. They're maps, they're composite maps of the typical rainfall impacts we've seen during previous La Nina events. There's a map for winter on the left and a map for spring on the right. And you'll notice that for Victoria, there's less of an influence on rainfall during winter than there is during spring. The winter map, we've got more of that white shading corresponding to sort of no strong push towards above or below average rainfall for a lot of the south and parts of the west and east. But in that map on the right, we've got more of that, we've got some of that blue shading showing a stronger relationship in springtime of rainfall. Now, turning to the other important ocean, the Indian Ocean, we have a phenomena out there similar to ENSO called the Indian Ocean Dipole. And last year, we had a positive Indian Ocean dipole. You can see that in the dashed black line in that chart in the top left. And that has sort of cooled down and returned to neutral at the beginning of this year. But there's general agreement between the international models, those colourful lines, that we're likely to see a return to that positive Indian Ocean dipole pattern in the coming months. Now, we're at the time of year where generally these models have their lowest forecast skill. So we have to take what they're saying with a grain of salt. And generally, the forecast skill improves as we move through autumn and towards winter. But you can see, again, it's the Bureau's model that's the most enthusiastic out of those bunch. Now, here's a snapshot of recent sea surface temperatures at the end of March. And if we start by looking out at the equatorial Pacific, the tropical Pacific Ocean, we can see a lot of warmth there in the center of the Pacific, sort of the sign of the El Nino. But further east, off the coast of South America, we can start to see some cool anomalies emerging there. Then over in the Indian Ocean, there's not a strong gradient between east and west, not a big difference between east and west, but we can see there is more warmer waters around the Horn of Africa than there is closer to Indonesia. We can see what the model's forecasting for this sea surface temperature pattern in a few months' time. This is the forecast for June. And we can see a bit more organisation in the tropics now. So those cooler sea surface temperatures off the coast of South America, they've enlarged and they're now stretching out towards the central Pacific. Perhaps that's, the beginning of a La Nina developing. And then over in the Indian Ocean, you can see now we've got a bigger gradient. We've got a bigger difference between the east and west. We've still got those much warmer than usual waters in the west, but we've now got some cooler than usual waters off Indonesia as well. But we can't ignore what's happening outside the tropics either. So taking a step back, we can just see how much red there is on this map outside, away from the tropics in both hemispheres. Particularly, there's a lot of unusually warm water in the Atlantic. And it's likely that these unusually warm temperatures outside of the sort of central Nino region could play or could act on the way any La Nina event evolves during this year. And the seasonal forecasts, the 1 month and 3 month forecasts, are a bit different from the 7-day weather forecasts that we're used to. And they don't have the same accuracy as those 7-day forecasts. And their accuracy changes for different parts of the country for different times of the year. So on these maps, these are past accuracy maps, and areas, the darker the green shading, the better the past accuracy for the forecast. And we can see that for Victoria, we have more of that dark shading or better past accuracy during winter, that's the map in the bottom left, and spring, the map on the bottom right, than we do for summer or for autumn. So that's another reason to be cautious of the forecasts at this time of year. They generally improve. We generally have better accuracy during winter and even more so spring for Victoria when it comes to rainfall. So now these are the long-range forecasts. This is for April, the month we're in currently. We've got rainfall on the left, maximum temperature in the centre, and minimum temperature on the right. And you can see in that rainfall map, we've got that area of green-blue shading corresponding to above average rainfall for a lot of central and parts of eastern Victoria, which we've already seen delivered or somewhat delivered at the beginning of this month. We had some exceptionally high daily rainfall for April. The maximum temperature map in the centre is telling us that parts of the state are likely to have cooler than usual maximum temperatures. Although it's not consistent right across the state, we can see there's a stronger signal in the northwest. But central parts too, some bias towards cooler than average maximums. And for minimum temperatures, there's no strong push for most of the state towards warmer or cooler than usual minimums, except for parts of the south, those areas around the Otways and the Prom with that red shading that are likely to have warmer than usual minimums. Stretching that out now to look at the coming 3 months, April through to June, the rainfall map on the left, a lot of that sort of beige shading for Victoria. So no strong push at the moment towards a wetter or drier than conditions for the 3 months. But the temperature maps are looking a bit more emphatic for that 3-month period. We've got more of that red shading covering the mainland southeast. So we're likely to have warmer than usual maximum temperatures. And the minimum temperature map, you can see some of that dark red shading covering southern Victoria. So high chances in those areas, so greater than 80% chance of having higher than usual minimum temperatures this April to June. And we can look ahead a little bit further for May to July, but the rainfall outlook doesn't change too much for us. It's still neutral for a lot of the state. However, there is a bit of a dry signal for parts of the Otways and around sort of South Gippsland or the Prom, and also for a patch of the northeast. But it's those temperature maps that are the far more emphatic. You can see now we've got that dark red shading covering the whole map for maximum temperatures, and for most of the state for that minimum temperature on the right. So really high chances of warmer than usual temperatures, but not a strong signal for rainfall. And as well as looking at those 2 category forecasts, the chance of above or below average, we can slice the forecast up into different ways. We can consider what are the chances of having unusually high maximum or minimum temperatures, where unusually means in the warmest 20% of the historical range. And the map on the left is showing what our chance of having unusually high maximum temperatures is. And you can see for parts of southwestern Victoria, there's sort of that 40 to 50% chance of having unusually warm maximums. But the minimum temperature map on the right is even more impressive. You can see right across southern Victoria, more than 50% chance of having minimum temperatures in the warmest 20% of the historical range for April to June. And as well as having the outlook maps, we can get forecasts for specific locations. So we're going to have a quick look at Melbourne, and we'll be able to contrast how much uncertainty there is in the rainfall forecast compared to the temperature forecast. So the plot on this slide, the coloured bands in the background represent the different rainfall quintiles throughout the year. So the dark brown is the driest 20%. The dark blue is the wettest 20% of the historical range for each month of the year. And then we have a box plot with the dashed black line tracking through the average of the forecasts, but the box giving us an idea of the spread or the uncertainty within that forecast. So even though the forecast for April is for better than average conditions, that's the average of the forecast. You can see that some members of the forecast were all the way up in sort of very wet, and some were down in drier than average. So quite a range. Definitely not a guarantee that we were going to be better than average. And looking further ahead, you can see that dashed black line tracking sort of just above that yellow shading into sort of the white shading, so near average or just below average as we look out through the months ahead. But now looking at the temperature forecast for Melbourne, you can see the boxes on the temperature plots are much tighter. Some of the forecasts still do span from sort of cool all the way to warm, but generally it's that they're sort of more tightly clustered than those rainfall outlooks. So you can see that in the maximum temperature forecast on the left, after some cooler than usual temperatures in April, we're likely to shift back towards average or warmer than average temperatures for the months out to August. And it's a similar pattern in that minimum temperature forecast on the right, where we're likely to trend in those pink or sort of red banded ranges, the warmer than average ranges in the months ahead. And before I hand over to Grant, I just wanted to touch on some of the really interesting weather patterns we've seen since the end of last year. So we had a fairly dry spring. Well, the first sort of 80 days of spring were quite dry, and that was expected with the El Nino, although we did get quite a burst of rainfall just at the end of November. And when we look at November, December, and January, those 3 months, that's the map on the left, we can see it was quite wet across a lot of the state. That sort of medium blue shading corresponding to very much above average. That's the parts that had rainfall in the wettest 10% of records for the November to January period. But after that, the tap really turned off, and you can see in the 2-month deciles map from February to March, that's the one on the right, large areas of red shading covering the state. So quite a turnaround, in the space of a couple of months. March rainfall was the lowest on record for Melbourne and some parts of the southwest. But really, it's when we look at the 2 months, look at February to March, that we see just how dry a period it was. So most of the southwest and parts of central Victoria, as well as around the Prom, coming in driest on record for February to March. And looking at temperatures for that same time, that February to March period, when we had sort of a lack of cloud, and a lack of rain, we can see those maximum temperatures, that's the map on the left, very much average for most of the state, except for parts of the northwest where it was highest on record. The minimum temperatures, the map on the right, not as extreme. So parts of the state having near average minimum temperatures, or parts of the west and south, although some warmer than average minimums too for parts of the northeast, east, and northwest. But as I mentioned before, since the end of March, we did have some record-breaking daily rainfall right at the beginning of April, and that has impacted soil moisture. So that large map in the centre there, a bit of a snapshot for how dry soils are, or soil moisture at the moment, what we call root zone soil moisture, the top 1 metre. And you can see the impact from that high rainfall at the beginning of April in that blue shading stretching from the northwest all the way down to the centre, down to Melbourne. But we still have some areas that are tracking drier than average in the east and the southwest. And looking forward, we've got the model forecast for May, is that map on the right. You can see soil moisture likely to be drier than average for a lot of Western Victoria next month. Now looking at storages, so water levels. The plot for Melbourne there on the left, showing that we're still at about 90% capacity, very close to the same level we were at the same time last year. That more polka dot looking map on the right, each of those circles is a storage, a dam or a lock. And the size of the circle corresponds to the capacity of the storage. The bigger the circle, the more water it holds. And the colour corresponds to how full the storage is. So those blue and green storages are dams that are sort of at or near capacity. And those sort of the beigey shaded ones are the ones that are sort of around that 50% level. So storage is generally fairly high across the southeast, heading through autumn and into winter. So just to wrap some of that up, in the coming decades, Australia will experience ongoing changes to its weather and climate, and we're expecting a continued increase in air temperatures, which means more heat extremes and fewer cold extremes. We expect to see a continued decrease in that cool season rainfall across southeastern Australia, but we will still have year-to-year variability. So when we see what phases those natural drivers are in, the Indian Ocean Dipole or the El Nino Southern Oscillation, they sort of add to those combined with that climate change trend gives us our year-to-year variability. Thanks very much. That's the end of my part. I'll hand over to Grant now.
Thanks very much, Jonathan. Get those questions into the Q&A section. I've scribbled a couple myself. It's now my great pleasure to introduce Dr. Grant Smith, who's an environmental engineer and science scientist specialising in oceanography. He's currently serving as an oceanographer in the research section of the BOM. He's deeply involved in marine seasonal forecasting. His research focuses on the impact of marine heat waves on marine ecosystems, shedding light on crucial environmental issues. So very relevant to us in Port Phillip Bay. So please join me in welcoming Dr. Grant Smith.
Thank you very much. So I assume you can see my slides. So I'm just going to go through some recent conditions and some subseasonal to seasonal outlooks for the region around the Victorian coastline and beyond. So when I mention subseasonal to seasonal forecasts, what I'm talking about there is outside the weather window. So the weather forecast window is 7 days, and then subseasonal is the weeks and fortnights after that, and seasonal usually is from the months to seasonal 3 monthly timescales out to 6 months in the future. So a lot of my research is regarding the prediction of marine heat waves. So in our corner of the world, southeastern Australia, the impacts of marine heat waves are varied. We've had several mass mortality events of some important habitats involving seagrass and kelp in the region. There is also impacts relating to invasive species, where a species that wasn't found in an area in the past is suddenly causing issues. And there's ongoing research at the moment about how the temperatures can link to the blue bottle populations offshore, and also research looking into how marine heat waves might impact pathogen levels in the water, and this has implications for public health. Now, whenever talking about sea surface temperature at the moment, it's hard not to mention this figure that gets thrown around a lot in the news and on social media, showing the daily sea surface temperatures from a global perspective. These made the headlines last year when the orange line for 2023 started moving significantly away from the grey lines of the previous years. And where we're at the moment is we're still very much skirting the line of highest temperatures on record, and continuing to do so. So in more recent years, so this is looking at sea surface temperatures along the southern region of Australia, from a temperature data set that uses in situ observation, so temperature gauges that are actually in the water. Last year, 2023 was the third warmest on record for this region in southern Australia, and our State of the Climate report showed that the Victorian region, including Bass Strait, some of the Great Australian Bight and into the Tasman Sea, is warming higher than some other regions around Australia, 0.12 to 0.16 degrees per decade. The past summer in this same region, this same southern region of Australia, so the summer period being the December to February, was in fact highest on record, using the same data set, above 1 degree above average. And all the recent years have been consistently higher than average in the summer in southern Australia. The plot on the map plot is using a satellite product to show how the temperatures rank for the December to February period. We can see some highest on records on the eastern side of Bass Strait, closer to the Tasman Sea region, and then very much above average and above average for the most of the rest of the region here. So even more recently, again, this is a daily satellite product showing good coverage across the region. The temperature anomalies in Port Phillip Bay are warmer than average as of the 3rd of April when this snapshot was taken. Outside the heads, there's some temperatures a bit closer to neutral, closer to 0. And then as we move to the eastern side of Bass Strait, we can see we're getting much more warmer anomalies in this region. The plot on the far right shows how this ranks in terms of percentiles. So the dark red is in the highest 90th to 100th percentile region of the data set. And there's a lot of this occurring in the east and parts of inside Port Phillip Bay and around some bits of the west as well. Now, this particular product is high resolution, so we can see some data from inside Port Phillip Bay. The remainder of my presentation will show products that don't really resolve Port Phillip Bay explicitly. It's more broader scale forecasts and observation products of what's happening outside Port Phillip Bay, because these products don't resolve what happens in there. So just keep in mind that that's what these products will focus on, but what happens outside the heads influences what happens inside Port Phillip Bay. The marine heat waves, when we refer to a marine heat wave, we're talking about that top 10% of temperature records. So when we exceed that 90th percentile, with the most common definition being that when the daily sea surface temperature exceeds the 90th percentile for 5 consecutive days. So this is a snapshot of recent conditions around Bass Strait. So currently in marine heat wave conditions, the marine heat waves are often reported in categories to show just how far above the 90th percentile they're going. So much of the region is in the moderate scale. So that means it's just going above the 90th percentile. But further over into the Tasman Sea, we have some much stronger marine heat wave activity happening off the coast of Bass Strait currently at the moment. So just picking a point in Bass Strait, just to see how marine heatwave activity has evolved over the last couple of years. We've had some significant activity occurring from mid last year towards the end of the year, and in recent months when we've hit that time of the year when we get those highest temperatures, we've been spiking with some marine heatwave activity again, and continuing to do so right up until the last observation here from this particular satellite product. So now look at some forecasts for the Victoria-Tasmania region. This is monthly forecasts from May to September. So looking at a calendar month, and what we're seeing on the left panel here is sea surface temperature anomalies, departures from the average. On the right, I'm showing model skill. So what we're looking for here is a green color, showing that the model has skill in these regions. The darker the green, the better. Regions where we're seeing white, we are saying that for these particular months, forecasting from now is poor to no skill. So in the months coming up, those temperature anomalies are likely to slightly strengthen across Bass Strait. Marine heatwave conditions that are occurring off the east coast of Tasmania have been persisting since, I'm not sure exactly when I first saw it. I think that might have been around mid last year, but they've persisted since, and looks like they're persisting all the way to September this year, with those temperature anomalies reaching the maximum on this scale anyway of 2.5 degrees above average and beyond. This next product, so we're showing the same sort of forecast from the same model. This is a probabilistic forecast. So our model also gives us an ability to produce this product that shows you its confidence on what it's predicting. So this probability is in terms of the probability of exceeding 1 degree above average for the region. So we can see that the whole eastern side of Bass Strait and into the Tasman Sea and off the coast of Tasmania, we have strong confidence in the model that the temperatures will be 1 degree above average for this region. And in much of the remainder of Bass Strait, there's very low probabilities. And looking at the skill for this, we get a lot of green color in Bass Strait, so we're quite confident with this forecast in the region. So these next forecasts are specifically marine heatwave forecasts. So they're based on sea surface temperature from the model, but now we're looking at the likelihood of it exceeding the 90th percentile again. And this is in terms of a calendar month. So we're looking at temperatures exceeding the 90th percentile for a full calendar month for May, June, and July. So in Bass Strait, we don't have much in the way of marine heatwave activity, but outside of this region, there is marine heatwave activity occurring closer, particularly in the Tasman Sea, encroaching into Bass Strait as we head closer to July. Now, everything, a lot of that temperature stuff I talk about has been relating to sea surface temperature, but it's also quite interesting to look at what's happening in the subsurface. So our model produces a parameter called heat content, which is a measure of thermal energy in the subsurface, which goes down to 300 meters. And it can be quite interesting to look at what's happening in the subsurface in terms of temperature to see if there's other features down there. It might be relevant for particular stakeholders, and also it's interesting to see how it differentiates from what's happening at the surface. So what we're looking at here is the last 7 days of heat content on the right, and I've just popped the sea surface temperature last 7 days on the left, just so you can see how the heat energy below the surface does show some similarities with the sea surface temperature, but there's also differences and departures from this as well. So what we can do with this heat content is also treat it like the marine heat waves for the surface temperature. So what this product here is forecasting is how the heat content likelihood of going past that 90th percentile is in terms of heat content. So down to 300 meters, where it's shallower than 300 meters, it still gives a value. It's just whatever the whatever level is available, it evaluates based on that. So in terms of the region, there's some similarities for the subsurface marine heat wave as there is with the surface off the east coast of Tasmania. So there's some similarities in the region there. There's a bit more coastal subsurface energy occurring along a lot of other coastlines around Australia, especially out to July. Interesting to see the Coral Sea lighting up in marine heatwave conditions in the subsurface, and a lot of the Southern Australia and Western Australia coastline as well. Now I'm just going to pivot last few slides here, just talk about a few interesting facets on sea level in the Victorian region. These three plots are showing the time series of sea level anomalies at a few tide gauge stations for Victoria. So what I think is interesting to note when looking at this long record back to the early 90s is some of the links to El Nino. So in 97, 98, for example, we can see a lot of blue negative anomalies during this time. This was one of the big El Nino periods. And there's a couple of others. There's some less severe El Ninos in 2002, 2003, 2006. Another big one, 2015, 16. And again, we see those negative departures, negative anomalies. So there's a strong link to El Nino in terms of negative anomalies, lower than normal sea levels on the Victorian coastline. And if we look right at the end of the record there, as we were heading towards the 2023, 2024 El Nino, we could see those negative anomalies appearing again. So they start appearing quite before the peak of the El Nino, before the summer of those El Nino periods. And there's a slight link with the positive anomalies to La Nina. It's a little bit less obvious, but some of those recent reds, for example, after 2022, that was past our triple dip La Nina. So you can see some links with La Nina as well in terms of it being a positive anomaly, but it's not as obvious as some of those negative anomalies. Now, where are we going from here in terms of sea surface sea level forecasts for the next few months? So this is a seasonal plot, seasonal forecast for the Australia region and Greater Pacific region. Around southeastern Australia, we've got some negative anomalies persisting on the west side of Bass Strait, fairly neutral in Bass Strait, and then positive anomalies off the the eastern side into the Tasman Sea. And then showing our skill plot again on the far right there, we're looking for green, showing that the model has skill for these sea level plots. And we have the green in the Bass Strait region and off the east coast of Tasmania. So we can be confident in the model skill for this region. So this shows you the departure from average conditions with sea level. It's interesting to look at what time of year is important. So this is the departure for the May July period. What does that mean in terms of what we typically expect for the May July period? So this last slide here is showing some research that was led out of the Bureau that looked at some of the seasonality of sea level extremes around Australia. So I highlight some of the Victorian points there. The May July period is when we get the most or the highest sea levels typically seasonally. A lot of these are tidally driven, so just based on the time of year when we would get the highest tides. But if we look at the colouring on the left side of that plot, this is sea level extremes, including other factors apart from tide, so such as storm surge, for example. So we can see that we get a bit more smearing of yellow in colour across the year, showing that we can exceed high sea level 99th percentile values in just about any month for the region. It just more commonly happens around that May July period as well. So we're entering that time when we're likely to get those higher sea levels, but the sea level forecast from our seasonal model is showing that the anomalies are likely to be neutral to negative. So the risk is normal to slightly reduced for the next few months. So just on this final slide, there's some links here to websites where I got some of these figures. A lot of what I showed is available. The marine heat wave forecasts are not currently available operationally, but there's plans in place for them to become operational later in the year. And so that's all from me.
Thanks so much, Jonathan and Grant. Definitely a lot more comprehensive than a standard weather report on the news tonight. So I think everyone has definitely learnt a lot more from tuning into this rather than the news. So thank you so much. We've got a couple of questions here ready to go. So we'll start off with Martin, who this one's for you, Grant. What is forecasting skill?
Sure. So we before we release a model operationally, we run what we refer to as a hindcast. So this is retrospective forecast. So we're forecasting the past, and we produce this over several decades. And because we knew what happened in the past, we can then go back and say, all right, let's look at how the model performed compared to what actually happened. And we use we usually have, for this particular model, for example, we have almost 40 years of forecasts that we've tested and looked at compared to the observations, and we can determine how much skill it has, how well did it forecast what actually happened in terms of the observations. And that's what we show here. So that particular skill metric I was showing is called a correlation coefficient. So we're just looking at the correlation between the last 40 years of forecasts and what actually happened. And that's a number that's between -1 and 1, and you want those numbers to be positive.
Great, thanks, Grant. So this one's maybe just to put it out to both of you or whoever wants to take it. It's a question around question from Sue, sorry, that says, do all of these statistics get shown to our politicians, specifically the Environment Minister and the Prime Minister? So maybe also just, how does, what the important science that BOM delves into, like how does that actually get reflected back into how maybe some management decisions are made? if that's not too tricky to answer.
Well, I was possibly Jonathan's better to answer this one. He might be a bit closer to some of those high level briefings that occur throughout the year.
Thanks, Grant. Yeah, certainly ministers and the government more broadly are aware of the work that we do and the reports that we publish. One of our biggest customers is the government, essentially, and providing them with information for decision making.
Great, thank you. So I have another question from Paul, which is for you, Jonathan, as well. So is there a correlation between soil moisture and coastal erosion?
That's a great question. For inundation, I'm not too sure. Sorry. I'd need to double check.
If I can take that one step further and maybe go to Grant and just about the currents, the part that ocean currents play in the ocean temperatures. Have we seen changes in the patterns of currents that again might correlate with what's happening with temperatures, or they're not connected?
Yes, I mean, so that, and this goes to Raymond's question online too. The temperatures off the east coast of Tasmania are being noticeably warmer. So this is linked to an extension of the East Australian current. Is what's driving that that patch there and driving that trend that we see in the region that's happening over the decades in terms of the increase in temperatures in this region. So along the east coast, this is something that we're seeing.
Yeah, just one more part, if I can, Shannon. With the you mentioned blue bottles, but what other marine life or ecosystems in particular are being affected, in the Victorian region, the southeast region? Yeah, what would be
well, I probably don't have too many additional ones as opposed to the ones I mentioned. The big ones that got well publicized at the moment, like the kelp forests, for example, is probably the main one for the region. Yeah, well, I mean, the blue bottle one's interesting because we talk a lot about negative impacts in terms of declining populations of flora and fauna, but yeah, there is also species that can increase in numbers. But yeah, this is an ongoing field of research. But yeah, in terms of other negative impacts, I mean, there's a lot discussed about the negative impacts for aquaculture and fisheries. Salmon in Tasmania, for example. You don't often hear exactly what's going on in some of these private companies, but there is an impact to that aquaculture industry in Tasmania as well.
And algal blooms, that they sort of fit in this realm of temperature change as well.
Yeah, well, that's another good one too. So yeah, the increase of likelihood of algal blooms.
Thank you.
I've got a follow-up from Paul's question for you, Grant, and just around that conversation around the impact on kelp forests and those mass die-offs. And we know that around Tassie specifically, and even parts of Victoria, we have seen a decline in giant kelp specifically. And there's heaps of restoration and work being done and research to figure out can we actually try and give that a helping hand. And maybe even just a plug for Mission Macrocystis here in Victoria. I'm not sure if it's in Tasmania, but looking at mapping where it is currently. So my question is there any other species of kelp that have been seen to be affected other than giant kelp?
No, look, you're going outside my area of expertise here. As a physical oceanographer, I don't know as much about things that is green or wiggly, so
no worries.
I probably can't help you too much with that.
Yeah, and that's fine. Thank you. Well, another question that I have, and I've seen a couple more have come from the Q&A. Sorry, everyone, I will get to your questions as well. But it was just more of a clarification from your previous comments around the reason for the fast changes in Tassie was because of the strengthening of the East Australian current. So is that the reason why we are seeing faster than average changes in southeastern Australia generally, because of that EAC influence, or are there other factors as well?
Yeah, no, I believe so.
Yeah, great. Okay. So, and I think you already answered this too before Raymond's question, but just checking if there's any other comments. What are the reasons for noticeably warmer ocean temperatures? Oh no, you've answered that one. So that one's all good. So a question from Peter, I think this is for you, Jonathan, on soil moisture again. What is the reliability of this data? And can you discuss the relationship to bushfire risk and soil erosion, which may end up in the marine environment and seagrass beds?
Yeah, so there's confidence in those observed soil moistures that I was showing from sort of in situ and remotely sensed data. And then the forecasts, we actually provide verification for all of the different long range forecasts. So I don't have it with me, but we can actually go back and see, like Grant was saying before, where the hindcast has performed well and where it, where it hasn't done as well.
Great, thank you. And we've got a question from Rebecca, which is a great question. So thanks for this. We know a lot about the effects on animals and plants, but does BOM also analyse how these weather patterns impact and will impact how people use the coast and experience their health?
Well, the Bureau doesn't sort of keep data on the usage, but it's certainly something that our stakeholders are very interested in.
Thank you. So another one from Sue, which might be out of the realm as well, but we'll just ask it. So what is the impact of increasing sea temperatures on migratory species such as whales?
Yeah, probably don't have too much to say on this question, but I do know that there has been interest in our forecasts where in recent months there's been a strengthening of the Bonnie upwelling on the western coast of Victoria, which is a spot that whales like. And that's part of the interest in that region, I think. Yeah, so that was a negative anomaly, so like a cooler than normal temperature for that region. So I know that much, but I probably can't speak more to what it means for increasing temperatures.
Yep. Great. Thanks, Grant. Any other last minute questions to come through? Otherwise, I think we've answered them all. Well, we might leave it there with our Q&A. Thanks so much, Jonathan and Grant, for your presentations. It was really great. I know I definitely got a much better understanding of weather patterns and the forecasts for what's going to be happening now in our weather systems and oceans. So yeah, it's I think it's a great privilege that we get to hear some of this and understand it a lot more. And hopefully everyone listening at home will have a greater understanding as well. And so when we see, for example, like those bigger tides at certain times of the year, we can actually know that actually they are forecasted and expected, and understand a bit more of those variations in what we see. So thank you so much again. And if everyone playing at home can join us to thank Jonathan and Grant, thank you. And for everyone listening at home, before we knock off the evening, just to let you know, we have one last webinar on the 1st of May, Adapting to Change, which is our last webinar. A bit sad of this series, but for those who have stuck with us for the whole time, thank you. And you might like to join our very last one, which we will announce the speakers very shortly. A big thank you to the Victorian Government for allowing us to proceed with these webinars, allowing us to run them. And also just wanted to give a shout out to Hayley as well, who this will be her last webinar. So thanks for all your work and support, and wish you, the best of luck going forward.
Thank you. And sorry I'm so sorry I've had tech problems that whole time. So yeah, thanks for having me and thanks for jumping in, Shannon. I really appreciate it.
No problems. Well, and thanks again, Paul, Hayley, Jonathan, Grant, and Jacob, who you can't see, but he's on the background doing tech stuff. So thanks everyone for playing at home, and we'll hopefully see you on the next webinar. This one it has been recorded and we will circulate it around, and details of the next one very shortly.